over, guys, and a couple of pictures to show you. Okay, so you guys remember how we did the lighting and the power for the project that we did? And it was, for the most part, it was easy. Lay out the receptacle based on the code, lay out the light based on the code, put the switches, circuit them, right, based on the criteria that we did. Now we're going to flip into low voltage system. When I talk about low voltage, guys, you're going to hear me talk about telephone. You're going to lay out your telephone jacks in the building based on the specification. TV jacks in the building based on the specification. We have a security system that we need to do based on the specification, and fire alarm system based on the specification. So that's for our project. So let's talk here. They take they're talking the project that we have in this book, guys, and they're talking about it in terms of low voltage. Okay, so let's go ahead and talk about television, low voltage system, signaling, and so forth. A few things, guys. Telephone and TV, and I want to emphasize the word, we're doing residential here. So we need a telephone and TV in residential. Antennas and cat TV, cables, cable TVs, and so forth coming into the NEC code book. There's article, chapter 7, guys, and chapter 8 in the NEC code book talk intensively about about the networking, bringing telephone and bringing cable TV into a building. So we're going to kind of touch on it as much as we can. Talk about satellite. There's a couple of nice pictures. Basically, how do you bring a coaxial cable into the building, right? Either from your satellite dish and from your provider, cable TV provider, landing into a splitter and get the signals inside your building. That's basically what this is going to be talking about. Then we're going to talk about chimes, the doorbells. The chimes are installing chimes. Chimes are a low voltage system, power limited low voltage system, guys. How do you install a chime into a residential building? So I want to remind you guys, we're doing residential only. Okay, so a couple of things, guys, about television. You can go from a very simple installation into a very complex installation. How many of you guys have installed a coaxial cable? Installed coaxial cable. Here's what you can bring. You can bring multiple coaxial cable from satellite dishes and one from the antenna. So say you have two satellite dishes. Here's two inputs. You have a coaxial cable coming from from the provider, right? Cable TV. Here's a third one, and an antenna, regular antenna. You can have 4 inputs coming into your building, into a splitter. From that splitter, you split the signal in wherever you want it inside your building. So that's basically what they're doing. It could be complex when it goes to a commercial building, guys. Closed cable TV gets more complicated. In residential, really easy. You'll see a couple of examples that we're going to be doing. Shielded coaxial cable is the most common things that we use. Installed, and all the stuff that we use right now is also concealed in the walls, right? Everybody knows you use coaxial cable for the TV, conceal it in the walls with certain restrictions, and you can't put them in power and lighting. Shielded coaxial cable installed in the walls. That's what you guys are going to do with me for this project, for the new construction. Here's what I want you guys to pay attention to. So bringing for you. Now, this is how you're going to do your project. Can I have thumbs up, Chad? We got it. Here's how you're going to do your project. We're going to assume for your project, there's something called the splitter here, signal splitter. We're going to assume you guys are bringing cable TV right in here. This is your input. You're bringing in input from the cable TV provider, okay? And outputs, you're going to go outputs for each one of these apartments. So each one of these apartments is going to have another splitter like this, and another splitter like this, 1, 2, 3, 4, and another splitter like this, 1, 2, 3, 4, and you can order this one with a fourth one in our case, 1, 2, 3, 4. So typically, when I ask you guys for this project to draw a TV riser for me, that's exactly what you're looking at. You're bringing an input into the building, coaxial cable. You bring it to a splitter here, designed. You can have 1 to 3 or 1 to 4 or 2 to 8. You can have more inputs and more outputs from the splitter as needed. Can I have thumbs up, Chad? We know where the inputs. These are out, Okay, so you bring the coaxial cable in, you split it into every apartment. This is apartment 1, apartment 2, apartment 3, apartment 4, right? You're splitting it into apartments. So inside every apartment, and you're going to have another piece like this, right? And inside the apartment, you're going to get that little piece and split it directly into every into all the location. So I'm going to have a bedroom here. I'm going to take one to the bedroom and so forth. So that's typically what you have, a splitter, and you split the signal. Can I have thumbs up, Chad? And what you bring here a coaxial cable. A coaxial cable. You guys have seen a coaxial cable? You have the inner core of the coaxial cable that carries the signal. Around it, there's a shield that shields the signal, protect the signal from being corrupted by the surrounding. So what do? You ground the shield as you enter the building, and the inner core, the conductive material inner core, that's where the signal is going to be carrying, and you land this one at your receiver, wherever your receiver is. Sometimes we have power here, guys. We provide 120 volt power into this device. Anybody have seen them? Where these splitter, they provide power, so boost the signal. They provide power. So sometimes we provide power here, 120 volt, special device that you have to put power into it to boost the signal. Why would we do something like this if we're sending the signal longer distances or splitting it more? Can I have a thumbs up, Chad? We understand that one? Cool. So if you guys don't mind, this is when I say draw a riser for your low voltage. That's exactly what, for cable TV. That's what you're going to be doing. Okay, so that's my inputs. A couple of things that you have to do when we have television, talk about the television, you have to have a receptacle right next to where your output is, right? Because TVs, you need to provide them with a power to power the TV and the signal, right? So you have to put an outlet for the television as well as right next to where the signal source is. So you have to have your receptacle and your TV jack right into the same area. So when you lay out your receptacles, Aaron, your TV, make sure you put your TV right next to the receptacle. Okay. So here's what they use, guys. The most common one that they use for signal. I'm not an expert in telecommunication. 75 ohm RJ-6 coaxial cable, shielded. That will the most common one. Bring the signal into you, shielded from the external interference, and dump that signal into your receiver. I don't know how much they use that old flat style. Not a whole lot. Antennas, okay. Central connection points. And then you can bring lead-in cables from the antenna, from cable TV, or from the satellites. So let me just go back here, guys. So right in here, what happens if what happens if you need a satellite? You take another input from here, and that will be your satellite. What happens if you need an antenna? Here's another input here that can come from antenna. So a couple of inputs and a couple of outputs. I personally wired a few of these where you bring multiple inputs and a couple of outputs to the same device. Or it could be standalone system. Each one of them has its own input and output. So keep in mind, every time you bring a signal, you bring it that combiner, and then you split them through the whole building. In our project, we only have, I'm asking you guys to bring a coaxial cable to the building and split the coaxial cable into every apartment like we've done here. And from every apartment, it's going to have a splitter like this that splits to a certain location based on what I told you. Bedrooms need one. I think a living room, I want one in every bedroom, one in every bedroom, and one in every living room. Okay, coaxial cable, guys, rules for axial cable right in this article in the NEC code book, 820. Go ahead and read this one. There's a lot of rules, but I can summarize it to you in a few hits here. So coaxial cable must be grounded. Very, very interesting. Here's what they do. There's a point of demarcation, they call it. When you bring your coaxial cable to the building, right as it enters, you have to go ground the shield. We ground the shield, not the signal. Everybody knows the coaxial cable have the signal in and the shield out, so you ground the shield as close to the point of entry as possible. That's required by the code. You bring the coaxial cable, take the shield, you ground it with number 14, copper, insulated or bare, and then you're done. You ground it where? You take it to the grounded inter-system bonding jumper, they call it, or a ground rod. That's it. That's what this, if you read through this article, ground it as it enters. Can I have thumbs up, Chad? We grounded it. Next. Then you take the coaxial cable. Do not run these in the same raceway or a box with electrical light and power. Don't we know that? Can you put a coaxial cable in the same conduit or cable or box with lighting, 120 or 240 or 470? No. Can I have thumbs up, Chad? We know that. Where does it tell you that? In Article 8.1. So these are a few rules, guys, that you have to be aware. Coaxial cable at least 2 inches. Maintain a 2-inch separation between your coaxial cable and your power cable. That's why, Jeff, when we drill through the studs, you drill one hole. You typically you drill one hole for low voltage, Cat 5, and all this good stuff, and one hole for the power. You separate them. So when you drill your holes, you separate the power from the low voltage. If you put them underground in a trench, you guys are going to be trenching, right? You're going to be trenching for me. When you put them, make sure you put a separation of how much? In the same trench. If you want to trench them, you're going to put your power. If you put them in the same trench, here's your power. You put, this is power, and then you're going to separate. You're going to have a separation 12 inches, and then this is where you put your cables, your coax. Separation of 12 inches in the same trench. You can put them in the same trench, separation of 12 inches. Typically, the power will be lower and the low voltage will be higher. Can I have thumbs up, Chad? We know how to separate them if we put them in a trench. Okay, so with power. Satellites, you guys are, so that's basically for the coaxial cable. There's a few things about the satellite. If you have a cable TV and a satellite, they're basically, technically almost the same, right? You bring a coaxial cable to the building, either from a satellite dish or from a cable TV. Can I have thumbs up, Chad? The same rule, you bring the coaxial cable into a receiver there, or into a splitter. If you have multiple receivers, you bring into a splitter and they split the signal into multiple receivers in the same building. And again, what do the satellite dish do? They receive the signal. There's a nice from the satellites and receive signals and send signals if you're doing it. There's a couple of rules for the authority. Here's, everybody knows, guys, how that system is. You generate whatever you want to generate right here in your telecommunication company. You send it through the satellites, and through this you have a dish. You receive that signal. Anybody ever heard of the term modulated signal, demodulated? Modulated signal, demodulated. Really cool. I did this one when I was in college. What they do, guys, they take your like my voice. You take your voice. That's a signal so small like this, okay? Tiny, your voice. And they modulate the signal. When they modulate the signal, imagine me, I want to go into Britain. I can't fly to Britain. So what do I need to fly myself fly? So what do you need? Modulate me is putting me in an airplane. So that's what they do. They modulate the signal and they put it in a much bigger, they put this signal into a much bigger signal. They let the signal ride into a much bigger signal, and they shoot it more powerful, and they shoot it through the air to the satellites. And when it comes over here, it comes as a much power signal, and there's a little signal riding with it, right? And so this is they modulate the signal, shoot it through the satellite, receive it, send it back here, demodulate it back here, and get that little voice or audio or video that you're looking for. So modulate the signal to send it through the satellite, demodulate it to take the voice out of that big bus that you put the signal in. So just be aware of that one. Obviously, these have to be grounded. We ground the satellite dishes and okay. Any comments, guys? Any questions so far? So coaxial cable, ground it as you enter, separate them from low voltage. Build in requirement for bonding. So we talked about the bonding. We have a picture about this one, guys. They call it inter-system bonding terminal. I have a nice picture of it, inter-system bonding terminal. If you need to know more about the television and radio, there's a few information that you can get here. At this time, for our need, what we have is good enough. A few things that you have to know, guys, for the antennas and lead-in wires. So you bring your antennas and lead-in wires, conductors from the antenna down. What do you need to do? Look at this. Does it make, goes without discussion, be securely supported, right? And attached to the, do not, I can't emphasize, do not attach it to the service mast. That's a violation. Your cable TV or your phone or your satellite coaxial cable coming in, can you put it to the mast that bringing the power? No, that's a violation. You can't do that. Even though if you go to old homes, they did it. Not attached to the poles that carry light and power over this amount. Higher voltage, you don't want to put it on the same, attached to the same pole. Lead-in connection shall be securely attached to the antenna. They talk a lot about, guys, when you read through these articles, they do two things. Number one, all these cables have to be secured. Number two, you separate them from power. Number three, you ground the shield. And number four is it has to be done in a neat and workmanlike manner. So don't do a sloppy job. All these low voltage articles, it talks about work. It has to be done in a neat and workmanlike manner, because we just got tired of people throwing all these coaxial cable wherever it goes, right? Keep antennas and lead-in conductors that you have away from the power and light. That's a big deal. Outdoor so again, separate all these systems, guys. All these systems from the power. You can see they can be repeating themselves. Should not cross over, the same thing, should not cross over the power conductors, shall be kept 24 inches away from the open light and power conductors. If you're outdoor on the same pole and you want to put them, take a coaxial cable from building A to building B, it doesn't happen unless you're on a farm or something. That's where you have to separate them, and the voltage is less than 25 to 25 volt, 250 volt. You have to separate 24 inches. So you put your power at the top, right underneath it, 2 feet, and you put your low voltage. Antenna conductors shall not be run under open light and power conductors. Open light and power conductors. Cables, no problem. You cable them, but not open conductors. You cable them together, no problem, but you can't put the open conductors. Any comments, guys, about these? So all the articles that you're going to be looking at here, it's really separated from power and ground as you enter. Can you have thumbs up, Chad? We understand how to separate them from power and lighting and ground them as they enter. Okay, so that's all what we want to focus in terms of the coaxial cable. I'm going to move into the so the cable is called coaxial cable that we use. We have a splitter. We ground it as it enters. We spread it through the building, separate from power and lighting, and you're good to go. Really, that's the bottom. We drill holes separate for the systems. Okay, so now for the telephone wiring, a couple of things for the telephone, guys. Telephone, it talks about communication, Article 800. A few things you need to know. After deregulations, as you probably, most of you are young here, so people can, the phone company right now, just all what they do is they give you a demarcation point. They give you a 4-conductor cable right inside the building. That's called the demarcation point, into a splitter for the phone line. Inside, how to run your phones is you run yours, or you have to hire somebody to do it. Okay? So I believe it's 22.4. 22.4 is the cable that you get. 22.4, so gauge 22, 4 conductors coming into your house up to the point called demarcation point, right? That's the phone. Now we move into the phone. Here's the phone, right in here. This is where the utility stop, right at this point, demarcation point. Is it here? My demarcation point, right here. This point is called demarcation point. They stop right here, and then from there, what do you do? From there, you can go for your phones, and you have either home run or daisy chain. I'm showing a home run. You can also daisy chain a bunch of them, like this, from the demarcation point, and you daisy chain them, or you take a home run. Can I have thumbs up, Chad? We know exactly how to do it. Yes, sir.
When you talking about the deregulation of the telephone companies, are you talking about, is that like back in the day when you used to have to buy your phones from
yes,
AT&T and all that?
And they used to have control over the wires, and now they are now yeah, they have to have control over the wires and control over the generation. Right now, the wires coming to your building, there's the wire companies, the company that owns the wires, and on the same wire, I can be a provider and use your wires that you installed as a highway. It's like, so in the past, you have your wire, you send on your wire. I can't send a new wire. Right now, for fees, of course, you have to pay fees, but I can use it. Any comments, guys? Any questions? They try to do the same thing with power, too, and it's almost didn't work. Okay, so requires. Here's what the code requires you. Article 800. Look what that came actually in 2008. They require you, the code 800 require you to have at least one phone jack wired to the demarcation point. That's what the requirement is. The code require you, 800 require you to have at least one required. And because, you know, when the only one in dwellings, only one, you have to put it anywhere you want, and you have to wire it to the demarcation point. Can I have thumbs up, Chad? That's the only requirement. Now, how many of you guys have only one phone in their homes? I mean, there's typically, unless you have wireless, you have multiple homes. A lot of people guys have multiple phone jacks. And I know there's wireless right now that you can do. But because of, anybody knows why they came in 2008? This rule came in 2008 because people like you are dropping their phone line, right? And getting what? Cell phones. They're getting cell phones. So, and because people are getting cell phones in 2008, this change happened. They said, well, the new construction building, they're not putting infrastructure for phones. They just bring the demarcation point right in there and stop it. No infrastructure. So they added it to the code, guys, to force the people to put the wire, at least one phone. Even because people are not doing it because of cell phones. So that's required, only one. Obviously, for the project that I have, guys, I can't remember. I think we're requiring one in every bedroom and one in every living room. And typically. So that's basically where the dwelling, one installed. This is the requirement. One install outlet installed to the demarcation point. I could tell you that Aaron, my friend, can't predict that. Can I put the phone line in the same conduit and box with power and light? No, just say no. Any low voltage system, guys, cannot be installed in a conduit or a box or a cable with others. Unless there's some exception, unless it's going to the same machine. If I have a machine there that bringing a power to power the machine and wires to control the machine, I can put them in the same conduit or cable. Okay, other than that, these have nothing to do with each other. I have a lighting circuit here and a phone jack. Can I put them in the same conduit, cable, box? No. If you put them in the same box, so I want to put them in the same box because they look really nice. What do you need to do? You have to have a divider. They have a divider inside the box. They make boxes with a divider. We can divide them into low voltage section, high voltage section. Then you bring your receptacle in here and your low voltage in here. Low voltage, and this is power. Say. Okay. So everybody's okay with that one. So if I test you guys and I said an example of, oops, there you go.
Separated by 12 inches.
That's if they're wires. 12 inches if they're underground.
Oh.
They're underground in a trench, 12 inches. If they're wires, separated wires, 2 inches. Separated wires. But these are inside a box. The code allow you to bring them inside the box, separate them with a barrier. So the box becomes, it's almost like two boxes, right? So one box coming here, low voltage, the other side of the box coming with high voltage. You'll see there's an example of it. Okay, here's how they do the phone, guys. This is my demarcation point, standard network interface, they call them. And you bring it to, this is called daisy channel. You can daisy chain your cables right now. Or you can have a home run. Everybody knows the difference between this is daisy chain, or I can have a home run coming directly from, I believe, from here to each one of these. Directly from, the problem with daisy chain them, the more signals you put, the more the signal is going to be weak. You can have a weak signals. So that's basically where you phone. A lot of people will do, guys, home runs directly into the demarcation point. Here's where you get your two pair at least. Here's your 2 pair. That's the bare minimum that you can get. 2 pair, and you get the green tip and the rings, red and yellow and black. These are all the color-coded conductors, and then you can get another 3 pairs for a couple of other things, and these are the color-coded for them. You don't have to memorize this, but this is a 2-pair conductor, or a 6-pair conductor. There's a 200-pair conductor, guys. And now with the, I don't even want to go there with the like 200-pair conductor they use for commercial building now. Coaxial cable can carry much more signals than that, number one, and fiber optics. Now with fiber optics, a lot of these guys, you bring a fiber optic to a building, and you split the signal from the fiber optics. You can get your voice, your data, and your TV directly from the fiber optics. So these are, some of it might be an old technology, but I want to remind you that right now the technology is you can have one coaxial cable that you can get your phone from it, your data as well as your TV, or you can have a coaxial cable or fiber optics that you can get the 3 signals, or you can have a phone line that you can almost get the 3 signals from it, right? A phone line, I have a phone line, I have my high-speed internet through my phone line, I have my voice, and you could, through the high-speed internet, you could sign with Infinity and all those good stuff, and you can get videos. I don't know how good of them, you almost need a coaxial cable to get good quality though. So my point is, all these systems, guys, are, with the digital age, are almost connected together. Can I have thumbs up, Chad? We understand? Okay, so that's what the pairs they use, but typically, what we're wiring for our project, guys, we're still doing it a traditional way. We're going to have a coaxial cable coming to the building to get us the coaxial cable is going to get us, I want you guys to decide, at least the cable TV, TV for all the apartments, and I need a phone line to give the phone lines. Now, the data, I require you guys to provide the data. I want you to decide, either you can get your data through the coaxial cable or through the phone line, DSL line or the coaxial cable. So what you do is, after that, is you take coaxial cable, bring it to a hub into every apartment, and you distribute the network, if it's either wired or wireless, into the apartment. We'll talk about this one when we go through it. Okay, any question about the phone and the data? Really, separate them from power. You ground the coaxial cable. If the phone comes underground, they always put a lead wire with it, guys, a copper wire, so they can trace it. You have to also ground the lead wire with it right at the point of it enters. Okay, the last system here in this book is signaling system. Signaling system or signal system is this is your chime. Your chime. Your chime is called class. Your chimes and doorbells and buzzers and all this good stuff, these are called signaling systems. Comes with the input. So a couple of these guys are your signaling system. Let's go back into showing you a couple of pictures about them, and then okay, here you go, Chad. All right, so let's go here. Now, a couple of things, guys, about the phone. We've said when you have a phone or a cable TV jacks, we don't put them in the same box. If you put them in the same box, they have to be separated. This is a couple of hardware you can do them. Okay, here's what a really nice example of coaxial cable coming. This is very nice. What I want you guys to draw this one, something similar when I ask you for riser for our building, the building that we have. So you're going to bring a coaxial cable that could be coming from an antenna, from a cat TV, cable TV, or from a satellite dish. The same thing comes to an amplifier. That's the splitter that we did. And from there, you can go and get your through coaxial cable again. You can go to all home runs directly through all your jacks in the building. If you do it this, and somewhere in between, guys, with the amplifier comes the receiver, I believe, and they come with different technologies. So if that was a splitter, you can come over here and put your receiver here in any one of these, and you can receive different signals from different outlets. Or you can put your receiver right in here, and then all these outlets, my understanding, I could be wrong because technology moves faster than I can talk. If you put the receiver there, you can get the same signal on each one of these jacks. So there's different, a receiver, guys, will control the signal that you're going to, which channel are you going to be watching. So if you want to watch different channels, If you want different channels, you bring your antenna in to an amplifier. That's a splitter with a power, basically. Amplify the signal, bring it to multiple home runs to jacks, and then right in every jack you can have a receiver. So I have my receiver in the living room, so my kids in the living room can watch whatever they want to watch, and then Mrs. Curdy and I will have our other receiver that we can watch whatever we want to watch in the bedroom. Make sense? But I think the technology is even different now. Could be where you can have one receiver wire it to different building, different rooms, and you can get also different signals.
Yeah, Dish network.
Yep. Dish?
I think Dish has that where
Yeah.
you need one receiver for 2 rooms.
One for only 2 rooms?
One receiver, two remotes. Yeah.
2 remotes. Okay. So then if you need more than that, you have to have another receiver.
Yeah, I think so.
So that's what I mean. There's technology is always move faster. So you could be with one receiver here, you can wire another room. And when they say wire, guys, mean you can watch different things. If you're going to watch the same thing, you can continue with the coax, and then you flip it. Every time I flip to a channel, all the coaxial cables that wire to this receiver will watch the same channel. Okay, so for the project, Aaron, my friend, I want you please to draw this one. For every room, we're going to have an amplifier and send a phone jack. In our project, guys, is going to be slightly different because we're coming from a splitter here. And then this is how it's coming to a splitter. Go to the apartment. We're going to do this in every apartment. 1, 2, 3. Does that make sense? So bringing a splitter to the apartment, we're splitting it to 4. Each one of them is going to look something very similar to this. Can I have thumbs up, Chad? We understand how to do that? The phone is going to be identical. The phone is going to be identical. Instead of coaxial cable, we're going to 22/4 cable, 22 gauge 4, to a splitter, split it into 3 locations. Inside every apartment, we're going to split it into 3 or 4 or more locations to go to every apartment. Can I have thumbs up, Chad? We know how to do that one? Okay. So that's basically what this is. Here's the splitter that we're talking about, guys, the input and the output. I think you can get 2/8. I did the 2/8. So 2 inputs, 8 outputs, or 1/4 or 1/2. I think if you go higher than 2/8, and again, my information might be dated, you might have to go to a commercial grade splitters with like amplifier almost. So there's a limit on how many inputs you can bring signal in and split the signal. If you have an antenna, guys, you know how to antenna bringing the power, the same thing, coaxial cable coming in, you ground it as it enters the building. Here's your receivers, and like you said, you can, if you have a satellite dish like this, you have to ground your satellite dish. Here's what I would like you guys to, inter-system bonding jumper. Can I have what the code? Oops, I will do your method here. There you go. Inter-system bonding jumper. This is called inter-system bonding jumper required by code. You are supposed to put this one right next to the service. So when you bring your coaxial cable in here, the shield of your coaxial cable, you bring a number 14 conductor and you ground it right in here. Number 14 AWG. Can I get you to understand this is required by Article 250.94 or Section 250.94? Now, when you go to the service, Andrew, when you become a designer and you go to the service, right at the service, you have to require the contractor to provide the inter-system bonding terminal, they call it, right by the service, right where the disconnect of the service is, or the meter is, right on the wall, for the low voltage guys to ground their system to it, because we're tired of them driving their own rod and then they don't tie the 2 rods together. Can I have thumbs up, Chad? That's they call it inter-system bonding jumper. I think it came, Jeff, in 2008 or 2005. I can't remember. Maybe 2005. I can't remember. 8 to 5. Here's how it looks like. Right next. Anybody have seen that? That's required in 2008, I believe, or 5. So you bring it right in here. So you bond all your systems. So if my coaxial cable is coming in here, one more time, you take the shield of it, and there's a slot right here, and you ground your system directly to it.
Yeah, Yeah, they don't, a lot of the time, because DirecTV and those guys are such hacks, they forget to do those. I had to put mine in myself.
This is required by electrical contractor to provide it though.
Yeah, but like if DirecTV comes, satellite, all that stuff has to be grounded.
Yeah. You know what they do to change this one, guys? Very good point, Jeff. In 2011, they put see that requirement? They put it in every single article in the low voltage system for the satellite TV guys and the phone guys and all those guys and the coaxial cable so they can understand it. Because in Minnesota, at least, we license those guys as power limited technician guys. And we require them to go for 16 continuing education hours. And they have 16 continuing, 4 of these have to be code. So they have to go every 2 years, like you and I renew our license. And it has to be part of the code. And they focus on the low voltage section, and right there, right now, it says 250.94. You have to ground based on this. Hopefully, they'll do it.
You have to do that, just install cable for like DirecTV or something like that?
Yeah, yes, for new construction.
But for existing, no.
Existing is a different story. You bring, because this has to be provided by electrical contractor, so your building is already built.
Yeah.
So for existing, here's what you're going to do. For coaxial cable, you drive a ground rod or you tie it directly to the existing ground rod, right? So if it's an existing building, then you can come over here and tie it to the ground, right? Number 14. To the ground rod. Either you drive a ground rod, tie it to it, or you tie it to the existing grounding rod for the building. Now, if you drive a ground rod, what do you need to do for ground rods, guys? 2 ground rods in the same area. You have to tie them together. Tie the 2 ground rods. We'll talk about grounding. So if I have 2 ground rods, one here and one here, this is for the power, and this is for the TV. So what do you need to do? The code required to do what? Bond these 2 together. Bond them together typically with number 6. Like you're looking at it right here, you bond these 2 ground rods together. Cool. Okay, so that's basically what you need to do. We talked about the satellites. Here's a nice picture, guys, of the antennas that you need to do. So look at this one. This is really multi-input receiver. So you can connect to terminals on the satellite antenna over here. So you can flip into cable. Look at this. You can have a cable or standard antenna, and then you have a satellite dish all coming to the same receiver. And out of the receiver, guys, you can get multiple signals. Anybody have a system like this? So you can get a signal from the satellite, a signal from the cable by flipping a switch here, or a signal from an antenna on the roof. So there's a lot of inputs, guys, and outputs. If you are to get into this situation, I strongly suggest talk to the vendors. There's so many, and these are moving target. They keep making 2 different things. But be aware that you can bring your satellite from one area, right in here, your antenna, as well as your cable TV into the same location. Can you have thumbs up, Chad? We know that one? Cool, thank you. Okay, here's how your satellite receiver, look at this. You have a phone jack, so you can control him, input in front of the input. You have multiple channels, satellite in, satellite out, multiple ins and outs for them. When you put your dish, guys, in the ground, you have to ground it. And look, they have some structures how to build that one. Line of utility, owner access, bonding connection to inner system bonding jumper. Where is that showing? So you have to bond to the inner system intersystem. So this is your phone, guys. You always have to bond the utility and the owner. This must be the phone line. So you have to bond it to the inner system bonding jumper. I don't think I have a better picture of that one. We talked about the home runs for the phones. Daisy chain them. Different phone jacks. Okay, the last thing I want to talk about, guys, before I let you review that one by your own. These are all the chimes that we use, and you guys look at them at your own. Okay, here you go. I'm going to go directly into the wiring. Okay, now for the chime, this is the one I'm going to focus on. Now this is for your door. I would like you guys for our project to provide a chime like this. So I want to emphasize the following. The code says for the chime, this is a class 2 circuit. You guys remember that class 2 circuit, 24 volt? These are 24 volt class 2 circuits. So right out of here, you have a maximum of 20 amp circuit coming in, maximum 20 amp to a transformer. Can you guys see the transformer here? This is a class 2 transformer, and then 24 volt go all the way to the there's the chime. There's 2 chimes here, one chime in the front and one chime in the extension chime recreation room in the back, typically front and back doors, right? So, and then you have a doorbell, one in the rear and one in the front, and that's how you wire them. That's how you wire them. You guys are going to do the same thing for me. You're going to take, you're going to have a chime in the living room, and you're going to have one chime. So we don't care about this. In our case, this would not be here. So one chime, you're going to have 2 push buttons, one in the front door, one in the back door, and they're going to be, you're going to typically 2 wires, 16-2 is typical, 16-2, twisted pair 16-2, that goes between here and here, here and here, and back into the transformer. Can I have a thumbs up, Chad? We know how this wires. This is called class 2 circuit, 24 volt. That's a typical signal circuit for basically for the door. Any comments? Any questions? We're going to do it for every apartment. Okay, now for the apartment, here's how we did it in the past. We did the doorbell for every apartment, or some people use an intercom. If you use an intercom system, go ahead and use an intercom system. So basically, you push the apartment with a buzzer, buzz them in so they can open the door for you. That's another. I have students did that in the past, put an intercom right by the main door and then you buzz the apartment that you want, and they have the solenoid, they activate the door and open the door for you. That's one way. I'm not asking for this for our project. So you guys asking for minimum of doorbell for every apartment. Can I have a thumbs up, Chad? We know what for apartment, one for every apartment. And that's how it's going to look like. Okay, so that's all I have for you guys. Any comments, any questions? I'm going to give you a 5 minutes break and flip into a different topic. Any comments, any questions? So we have 5 minutes and then flip into, please read this chapter. It's not hard, guys. Coaxial cable and twisted pair. That's all what we're doing. And the next chapter, guys, is going to talk about fire alarm system. So I want your attention here. Let's take 5 minutes. And touch on these. So here's what I would like you guys to focus on. Please, before you start even doing your system, please read these, guys. Here's a few things we're going to focus on. These are your fire alarm system, smoke, heat, and carbon monoxide system. That's your fire alarm control panel system. When we go to the commercial project, Joe, my friend, we're going to talk about a standalone, complete fire alarm system, where you have a fire alarm control panel with a fire alarm annunciator, with all the smoke detectors and heat detectors, and all the horns and strobes coming to that device. Okay. The second system that we're going to talk about, guys, is your security system. Your security system is called class number 2. Class 2 circuit. Class 2 circuits, these are power limited circuit that you use for security system. For example, you're going to have a pad where you're going to program the security system. Somebody break into the glass right here. You're going to have a glass break detector. It senses the frequency and ignite and sends the horn, turn the horns on. So a couple of things. So this chapter talks about 2 systems, fire alarm as well as security. Okay, before I get you in there, guys, I want to remind you, for those of you who are going to be lucky enough to work on fire alarm system, you're going to be dealing with NFPA 72. NFPA 72 is called National Fire Alarm Code. National Fire Alarm Code tells you where the systems are, how do you put a system in a building. So we'll talk about this one in less than a second here. And also National Electric Code, this is our baby here. The National Electric Code say if you have to put a fire alarm system in a building, this is how you have to wire it. Cool? Can I have thumbs up, Chad? That's the 17 NEC code book say this building needs a fire alarm system, right? Now, what type of cable? How am I going to install this cable in the plenum ceiling? That's where the NEC code book is going to be your friend here. We'll talk about the difference between smoke detector, piece of cake, it senses smoke, heat detector. Anybody can guess what a heat detector senses? See? Carbon monoxide detector. Anybody sense what a carbon monoxide detector senses? Carbon monoxide, that gas that's senseless. You can smell it, you can see it, but it can kill you, right? Produced by, we hear a lot here in Minnesota, produced by combustion, combustion, not complete combustion of natural gas and so forth. Requirement for installation of these systems, we'll talk about these one, guys. Minimum acceptable level of protection, we'll talk about these. So this, we're going to say, where do we need these systems and how do we install them? Can I have thumbs up? Fire alarm and security. Let's go ahead and go through that one. Understand the location requirement. Where do I need the smoke detectors and a heat detectors? The minimum requirement. Obviously, maximum requirement, put them wherever you want. We'll talk about the minimum requirement. Security system. We'll talk about security system. Security system is really kind of custom initiated and system. There's no requirement for where do you need the security system. Obviously, there's recommendation and best practices. Okay, standards covering fire alarm equipment, UL and fire alarm equipment labels and so forth. That's another good things to focus on. Okay, 70. Here's the difference between 72 guys and the fire alarm. The code that talks about fire alarm, National Fire Alarm Code 70E. Here's what it does. It just goes through the hole to protect the building from fire alarm. You have to put your smoke detectors in the following location. It goes through the whole location. And when you wire them, you have to tie them this way. And it goes through the details of tying them together. Smoke, so the focus of it, smoke always comes before fire. So if I can sense the smoke, what do you think I'm going to do? Stop the damage and the casualties of fire. Just a couple of things, guys. Fire, homes fire. Smoke and fire is the major, the primary means of protection against fire in homes, because you sense the smoke, people can leave, then you protect people's lives, right? Chapter 29 in this document, I do have one in my office at home, as a matter of fact. Chapter 29 talk in particular about single family and multi-family dwelling in our case. Single and multi-family dwelling. We're going to do it for single multi-family dwelling. I will summarize it to you in a second, guys. How we do it. So Aaron, my friend, we're going to focus here on only dwelling, single and multi-family dwelling. We're not going to talk about we're not going to talk about commercial building, because that's coming next Friday. So 29 in 72. Anybody have ever had a copy of 72? Seen a copy of 72? Should have brought my copy with me. Tells you where do you need these systems. Okay, small residence board and care occupancies. So this is just a couple of definitions, guys. Small residential board and care occupancies, a building or a portion of a building used for people to sleep in for more than 4 people. That's all defined in 72, not related by blood and so forth or marriage, for the purpose of providing personal service care. So they're defining the care occupancies, hotels, motels, and so forth, because that's also the requirement. Okay, this is where I want you to wake up if you're sleeping. Here's the article, and here's the difference between this chapter will tell you where to install a smoke detector. Very, very interesting. And a heat detector and alarm in a home. Where? Can I have a thumbs up, Chad? If I want to know where do I need a smoke detector in this apartment, can I go to the NEC code book? Would you find anything in the NEC code book that tells you where do you need a smoke detector right now? No, you wouldn't find anything in this book. Where do you need to know, where do you need the smoke detector in an apartment? You have to go to the 72. Luckily, the book that we have, guys, summarize the location, so you don't have to go at this moment to that location. And if you go into this one, all the fire alarm have to be installed based on the listing and the manufacturer instructions. Everything, guys, in an EC code book and the 70T will tell you have to be listed. The equipment have to be listed for the purpose, and they have to be installed according to the manufacturer instructions. Okay, so the thing I really want to distinguish between is an EC code book, Article 760 that talks about fire alarm system. In this one, guys, in this one, that one here, okay, it talks about the wiring, how to install the wiring for the fire alarm system. Can I have your attention for 1 second? So if I want to know where do I need the smoke detector, where do I go? You go to 72. If you want to know what type of wire to use for this smoke detector, where are you going to go? To an EC code book. Everybody knows the tie between an EC code book, Article 760. We'll talk about this one, guys, in the commercial too. Article 760 tells you what type of wire do you need to wire the fire alarm system. Now 72 tells you where do you need the fire alarm system. Can I have thumbs up about the difference between the two? Okay, good. Combination of smoke and smoke alarm and detector. Okay, important terms to know when we talk about the fire alarm system, guys, and when we go to the commercial, Jeff, my friend, and Zach, when we go to the commercial, we bring a fire alarm, low voltage contractors come here and they give a full spiel fire alarm control for the whole building. You're going to hear from the mouth of the lion, like you say. But this is just a quick important terms that you need to know. We have the alarm to signal that there is a situation. We have a heat or a smoke alarm. We have the detector itself. So really the fire alarm system is made out of mainly three things. You have the brain, the fire alarm controller, right? You have the inputs, the smoke detectors and the heat detectors, and you have the output, the horns and the strobes that tells you there is a fire, get the heck out of here. So these are part of it. Heat versus smoke detectors, household fire alarm system. This is what I'm going to focus on. This is how we're going to design ourselves based on household fire alarm system, which is basically these smoke detector. We have the horn, strobe, and the detector all in one, right? Everybody can see that. I'm sure you've seen it. Combination detector that goes with what we're going to be doing for this project, and single versus multiple station alarm. So I want you guys to focus, at least for this project, on these two. We're going to have a combo detector that can detect an alarm for this dwelling done. We're not going to have a full spiel fire alarm system where you're going to have a fire alarm panel, controller, and so forth. We're going to do this one next project. Can I have thumbs up, Chad? Okay, so that's where makes it a little bit easier. Okay, dwelling unit, living area, sleeping area. You have to understand that's where the 72 deals with. It requires you all in dwelling units, people live living area as well as sleeping area, people where people sleep in. All these are required to have smoke detectors. We'll talk about this one in a second. Okay, so why do we have all these detectors? To give the occupant early warning to get the heck out of there because there is a fire or there is a gas that could kill them. Usually contain both the detector and the alarm. And in homes, this is what I want to focus on. Home type smoke or heat detector, they can have both, like we said, contain both the detector and the alarm in one. The detector and the alarm in one, right? That's what the focus of this project, please. So don't think we're going to be doing a strobes and heat detectors and smoke detectors all over. We're not going to be doing that for this project. Come on, can I have thumbs up, Chad? We're going to have a detector, a combination detector that had smoke detector as well as alarm, which is the strobe and the horn, all in one. Okay, One thing you need to understand, 70E require two sources of power. Can I have you guys to understand this one? Source number one is a battery, and source number two is a power. So every smoke detector have to have two sources of power. The combo, we're talking about the combo now. The combo has to have two sources of power, right? When you open them, guys, what do you see? A battery inside them, and they have to be hardwired for new construction. If you have a full steel fire alarm panel right here, guess what they do right in here? They bring a 20 amp circuit to feed the fire alarm panel, and inside the fire alarm panel, guess what they have? A battery, two sources of power. Two sources of power. Can I get you guys the two sources of power for the fire alarm system? It makes a lot of sense. You lose electricity, you don't need to lose your ability to sense that there's a fire. Interconnection. Interconnection is required in dwelling and elsewhere. So interconnection, guys, you have multiple fire alarm system in your house on this apartment. If one goes off, what happened to all of them? They all go off at the same time. Makes sense, right? If there's a fire in the basement, do you want to, and you're on the second floor, do you need to know that there's a fire in the basement? Yeah. So they all interconnected, and they wire them interconnected. New construction, you can't have the plug-in ones. The old ones, yes. So everything has to be wired. If you have people who cannot hear, they have a brighter strobes that for them, special time. They have brighter strobes where they can see the you can't hear, so you need to be able to see. That's why almost all of them, guys, have two alarms. Have a visual as well as audible alarm, right? You have the horn and the strobe all in one. Anybody ever wonder why? Because if you can't see, you can. If you can't hear, you can see, and hopefully, it will give you also a guide to where the entrance, the exit of that building is. The exit of that building is. Okay. Low power radio wireless system. So they can have a wireless system, guys. I don't know if it's approved or not. Alarms must be interconnected so that they all sound when one sounds off. Standard for single and multi-family dwelling. Couple of standards. Very powered for homes without an alarm system. So we'll move into that one. Here's what I want to focus. This is how I want you guys to do this building. Can I have thumbs up? The building that we have, we're going to have a smoke. These are, you bring a 15 amp circuit to the first smoke detector, and this circuit will be coming from typically lighting circuit. It's not a dedicated circuit. It's a lighting circuit, right? And you feed your smoke detector. So Kerry, my friend, when you did your lights, go grab a lighting circuit now for Chad, and you're going to put the smoke detector in every bedroom, every living room, and every level. Every bedroom, every bedroom, every hallway in front of the bedrooms, and every level. We have two levels, so your partner is going to be taking care of the level 2. You're going to take level 1. All the hallways in front of the bedrooms are going to have one, and every bedroom is going to have one. So for the most part, you guys are going to end up with what? 2 bedrooms. We have 2 bedrooms plus a hall with 3 smoke detectors. They're going to be typical. So here's my bedroom. Bedroom number, bedroom 1. Here's my bedroom 2. Bedroom number 2. And this is my hallway. And you bring the circuit, one of these circuits, and you connect it together. The black and the white is to power the devices, to give them juice, to power them. Anybody can see the red here? Anybody knows why the red is? The red is a signal. So if this goes off, what do you think for the other 2 will do? Will go off too. And all of them have batteries. All of them have batteries on it. That's requirement by the 72. Can I have thumbs up? Say, Chad, this is exactly how we're going to wire this apartment. Cool? All right. So that's basically the requirement that we're going to have. Now they have types of smoke detector, smoke alarms, guys. We're going to talk about this one, this next project when we bring our speaker about fire alarm. There are photoelectric and there's ionization. Photoelectric is inside, there's a little chamber and they shoot a beam, the beam inside the chamber. When the smoke gets into that chamber and block the beam that's going from point A to point B, sensor, when it blocks it, it goes into alarm. That's it, as simple as that. So there's a beam hitting there, you get smoke, small amount of smoke in here blocking the beam, guess what you're going to get? You're going to get alarm condition. This guy, ionization. We have a radioactive source, ionizes the air inside the chamber, which causes current to flow. So radioactive material, instead of a sensor now, right? Photoelectric, a beam going there. You have an active radioactive material creating electrical current. If you have smoke inside that little chamber, guess what's going to happen to this current? It's going to stop flowing. When the current stops flowing, they sense that there's a smoke in the area and goes into alarm condition. Can I have thumbs up, Chad? We will talk about these technologies more as we go into the full Spiel fire alarm system in the commercial project too. So in either way, it impedes the flow of the current or the sensing mechanism of the photo, the beam that's going when the smoke gets into it. Okay, so that's basically the two technologies that they have. Then they have for heat alarm, they have multiple technologies that they use for heat alarm. We need smoke sense for smoke. What do you think heat sense? Heat. Okay, I'm not asking you for heat detectors, guys, in our project. If you want to put a heat detector in a building, commercial building, in a house, where would you put a heat detector? Anybody can guess? No, where in the house? Like in the kitchen, living room, bathroom? Kitchen. Kitchen would be a good application for a heat detector. It's not required. Why? Because kitchen, if you put a smoke detector in the kitchen, what happened? Nuisance tripping. You don't want to be nuisance tripping. So a heat detector would be a good application in a kitchen. Garage could be a good heat detector, good application for a garage too. Okay, so the technologies that they have. Technology number one, guys, is fixed temperature. The temperature hit 100 or 110, it goes into alarm, right? That's fixed temperature. They fix a certain value. The other one is rate of rise. Here's how rate of rise is, guys. The temperature was 70 degrees Fahrenheit, and within seconds it jumped from 70 degree into 100. How would the temperature go within seconds from 72 to 100? You have a flash fire. Fire is just flash fire. So that's they call it temperature rise. The temperature have risen so fast in a short amount of time, it goes into alarm. These are very powerful when you have these technologies together. Okay, the third one, guys, is two of them together. So you can, which is the best one, you can have, if the temperature slowly goes higher than the limit, it goes off. And if they have a flash fire and it went so fast, heated so fast, the temperature to a certain value, it will go off too. Okay, so that's basically, and then better of all, then you can have a heat and smoke detector in one combo. Heat smoke detector in one combo. Right? You have smoke, senses smoke, and also senses heat. And it senses fixed heat or rate of rise. Can I have thumbs up, Chad? Rate of rise and smoke. Okay, so that's these are the technologies they have. Now, here's where you guys are gonna wake up. Where do I need smoke detectors? Smoke, not heat. Smoke detectors in a dwelling based on 72 and FTA 72. You need it in all sleeping areas. Outside the sleeping areas, all levels of the residence and guest rooms, bedrooms, and suites, like hotels and motels. In our area, we're not doing a hotel motel, are we? No, we're doing an apartment building. So you're going to put it in every bedroom, and in every hallway in the front of the bedroom, and and you have to put it also in every level if you have multiple levels. Cool. Can I have thumbs up, Chad? In your building, we have four apartments. The apartment's going to have one in every bedroom, one in the hallway in the front of it. Now, how about the common areas? The common areas, what we do, we end up, guys, putting one in every common area, smoke detector, and we wire the common areas all together. Cool? Okay, a few things, guys, about how to put the smoke detectors. And there's a couple of pictures really nice that summarize all this stuff. Okay, talk about the pictures. Oops. Here's where you need them in every bedroom. Can you guys see that? In every hallway, every bedroom, and every hallway in the front of a bedroom. Make sense? So does that give you an idea how you wire your house, your apartment right now? No problem, Chad. Okay, now this is one of the most important things. Now we know where to put them, in which area. Now, where in the room we need to put them. In the past, guys, typically in bedrooms, you put them as close to, like within the, if this is the door for the bedroom, you put it right in here for two reasons. Number one, it also points to the exit of the room. So you wake up in the middle of the night, and it's because of the noise, and the light is flashing, so it points directly to the location we have to exit because of fire. So you put it, instead of putting it in the middle of, you can put it anywhere you want, as long as you meet this criteria, but typically you put it right close to where the door is. Here's the places where you don't want to put it. These areas, guys, number one here, it's called dead area, right in here. Can you guys see that one here? Dead areas, which is 4 inches, 4 inches in every direction, 4 inches, 4 inches. You don't want to put it in the corner, right there in the corner. Anybody knows why? Because the smoke takes forever. Yep. Yeah, it takes forever, rolls over that little area. So you don't want to put it within 4 inches of the ceiling and the floor in that little corner. Can I have thumbs up, Chad, about this area here? Okay. The second thing, so that's number 2, mounted alarms. So then you put it in the center of the rooms. You want to put it in an area, you can see where the location are installed in the center of a room. In every level, look at every level has one, at least one, right? Attic, if it's accessible, you have to put it in the attic, mounted on the bottom edge of the joist, the space between these joists. This is where you get 36 inches. You have to put it 36 inches, I believe, down from that little location. So this will give you, if you're an installer, we're not installers. Where do we want to put them? Bedrooms and hallways in front bedrooms. When you install it, where you're going to locate them in the bedroom. Typically, if you come over here and you move like 4 feet away from the door and you put it right there, don't get it closer. As long as you don't get closer than 4 inches from the walls, you're good to go. Can I have thumbs up, Chad? Can I put them in the walls instead of the ceiling? Yeah, but don't get closer than 4 inches to the wall. So I can put them right in here. Typically, we don't put them in the walls. Where do we put them? In the ceilings, closer to the door. Thumbs up. Any questions, guys, about this? So that's really summarized the whole installation business here. Here's where the area is. Oops. Go back to here, where it tells you the edge of the alarm, so where you can't put it within 4 inches right here. Do not install in this area because the smoke is not going to roll over. It's not going to reach it. This is the same thing, guys, where the 4 inches where you can't go, and they have that 36 inches. Can get you from here to here, so you have to do the math how far you can put to install if you have a sloped location. So where to put your smoke detector in here is your 36 inches. This area is a no for location, as you can see. So these are a few pictures, guys, that tells you where to install them. As long as you stay away from 4 inches of the ceiling and the wall in that corner, you're good to go. Can I have thumbs up, Chad? We understand that one. Maintenance and testing, you're supposed to test them, guys, regularly. Inspect, test alarm monthly. So you guys go ahead. This is based on 70. There's a test button. You're supposed to do them monthly based on the manufacturer instruction. And every 10 years, what do you need to do with them? I don't know how many of us would do that. Anybody have changed them every 10 years? Supposed to get rid of them. Smoke alarms where they fail to respond to tests or after 1 year. So if they don't test, then they're not working. You have to replace them. But even if they're working after 10 years, you're supposed to, based on recommendation of 70, you're supposed to get rid of them. Any comments about smoke detectors? Carbon monoxide detectors, guys, detect for carbon monoxide. I think in Minnesota, it's required at least once in the building. One of them in the whole house, in dwelling, it's required once. It could be plugged in or hardwired, but you have to have 2 sources of power for it. If it's plugged in, it has to have a battery. If it's hardwired, of course, it has a source. It protects you from this deadly, Jeff said it's myth, carbon monoxide. Why? Where does this produce? Because of incomplete burning of fuel like natural gas. It doesn't burn complete, so create this gas, carbon monoxide, which is deadly. So here's the problem: odorless, colorless, and tasteless, and highly poisonous. So you want the gas odorless, colorless, and tasteless in your house, and highly poisonous. So in Minnesota, you're required to have one in the house. For you guys, here's what they have in combo though. They have a smoke detector and carbon monoxide detector in one, hardwired. So why don't you guys get one of these, at least the one in the living room in our project, indicate that this particular one in the not in the living room, in the hallway in the front of the bedroom, indicate that this will have carbon monoxide detector function in it. Can I have thumbs up, Chad? We know that we need at least one. Okay. This is what we said, at least one in every apartment in our case. Warning before deadly gases, provides early warning for the deadly gases. Why it announces that deadly gas, carbon monoxide, it goes off, and it protects you from that gas. Okay, 72 is recommendation. Okay, so we know where to install them. Now going, guys, into this article in the NEC code book. The NEC code book take the fire alarm system and divide it into two systems. Jeff, there is power limited fire alarm system and non-power limited fire alarm system. Most of the system are called power limited fire alarm system. They run at 24 volt. They're power limited, so people can work on them. The non-power limited fire alarm system, they can work up to 600 volt, and the amount of juice in it is unlimited. Okay, so most of the time you're going to go 70C talks about power limited fire alarm system. Here you go. Power, non-power. These are the two types: non-power and power limited. Can you guys make a couple of checks here? Next quarter and the quarter after, next semester and the semester after, we're going to be always working with power limited fire alarm system, a 24 volt AC fire alarm system on the wall, and we're powering all these horns and strobes, and everything else is going to be 24 volt power limited. Can I have a thumbs up that we understand it? Now, if it's power limited, you guys can guess the answer for this. If it's power limited, right, do you think you can put them in the same conduit? The wires for the fire alarm system, can you put them in the same conduit or box with any other power and lighting circuits? That's it. You have to separate them. If you put them in a plenum ceiling, it has to be plenum rated. If you put them in a riser, it has to be riser rated from floor 1 to floor 2 because of the weight of the conductor. So these are what this article talks about, the type of the wiring that you can use. And we'll talk about these when we go to the full spiel. Any question, guys, about the fire alarm before I move into the security system? So 72 tells you where to put them, sleeping area and hallways in the front of it. We need smoke detectors. Heat detectors, it's up to, there's a lot of recommendation where to do them in dwellings, guys. It's up to us to decide where. If you want to go ahead and put one in the kitchen, that's fine with me. Carbon monoxide detector, you need at least one. So make the one in the living room as your carbon monoxide / smoke detector. They're all going to be interconnected, and they're going to be the combination type in our project. Means the alarm and the detector are all in one. Okay. We talked about 760 talks about the wiring methods. By the way, 760 doesn't apply to us. What we're doing right now does not. This article does not apply to us because we're pulling a combo. We're pulling a combo. A combo is all in one, and they're running at 120. It has nothing to do with it. Okay. Any comments, guys, before I go to the security system? Any question? And again, Jeff, this is just intro for dwelling. As we move forward, guys, we have a full spiel fire alarm system for the commercial building that we're going to have. Security system. Security is owner provided. It's not, the code doesn't say anything about you have to have a security system. It's up to you. It's a class, I want to remind you guys, it's a power limited class 2 circuit. It could be installed by the owner or professionally installed. It could be very simple or very complex system with, you could have a security system where it activates a machine gun. So, or you can have a security system that just shouts and horns. So here's a couple of things that you need to include with your security system. Master control panel, that's your security panel. Motion sensor, so if a thief moves in, it sends and it alarms. And interior and exterior sirens, interior and exterior typically. And all these security system is coming from which article? 725, and it's class number 2 circuit. So here's Joe, a class number 2 circuit. Can I put it in the same conduit or box with anything else? No. Can you guys see how these articles start repeating themselves? All of them? Any question about the security system? For our apartment, we're required to have a security system for every apartment individually. And I have a requirement where what I want you guys to do, motion detector, glass break, and a bunch of other things. We'll go over this one in our requirement for the apartment. Okay, so let me go show you a couple of things here, and then I'll let you okay, we talked about smoke detectors. Okay, I can't emphasize this picture, guys. This is how we're gonna do the fire alarm in our building. Can I have thumbs up, Chad? We got that one good. All right, so we got this is with its location. We talked about the location. This is very important to read through, guys. The most important thing is not to install them in these corners here, right? So we got that. The same thing here, not installation requirement, no, 72. Okay, we talked about these. Security system. This is a couple of things about the security system motion detector. You can see, guys, activation and horn and strobes and so forth. The last, here's what I would like you guys to pay attention to, if you don't mind me saying that. If I can get you guys to be here, this is where your security panel is going to be located. You guys are going to provide a security panel that looks something very similar to this. This is my security panel. Through your security panel, I don't know if you guys can see, here's a glass, break, door, contact, floor mat, so if they're walking, door openers, window, contacts, all these are coming to your security panel. Keypad, this is your key. Anybody knows why the keypad is there? What do you do the keypad for? Keypad is going to be for, here we go, coming in. Your keypad is going to be for to program the security system. You need a telephone line. Why do you guys need a telephone line for your security system? Call the security company, that if you want to hire a security company, so they can come check on the door. Key operated remote switches. You can have key operated remote switches that can activate if somebody is to get in here, activate and deactivate these. So all these guys are your outside alarm horns. All these are inside and outside alarm horns. Strobe light. All these are part of your security system. You can have an auxiliary contact here that can come in and I don't know, open or close certain doors if you have a situation. The only thing I want you guys to avoid putting here, smoke detectors and heat detectors. These, can you see these? These I'm going to move them into typically fire alarm control panel. So typically we have two systems. One is fire alarm control panel, where you can have the smoke and the heat detector, put them into that fire alarm control panel, and security panel, which you put all this stuff in the security panel. And the two panels can talk to each other, right? You can, for example, you go to Home Depot, guys, there are doors that are locked in the back because of theft, right? You don't want people to steal things. But by code, you have to have these doors open up on the existence of fire. So guess what happens if there's a fire alarm in the area? There are latches, and the fire alarm system, the first thing they do is go unlatch these doors in the back so people can't get out if there's a fire condition. Otherwise, you're going to be locking them in one corner and burn them down there if there's a fire. So these are all where the doors have supposed to be an egress doors to exit the building if there's a fire alarm system. But for security, you have to lock them because people can steal. So you lock them, but if there's a fire, it's interfaced. So the lock is interfaced with the security system. The security system is interfaced with the fire alarm system. So what happens is immediately you get a fire alarm, it sends a signal to the security system, it opens the doors or unlock the doors so people can open them. Any question, guys? Any questions? There's also interface between the fire alarm system and the elevators. You have a fire in certain area, it shuts down the elevator. It brings it down to a certain floor and opens it. And it doesn't run. There's a lot of interfaces, guys. Fire alarm system interface to, we'll talk about this with air handling unit. You have fire alarm in the area. Do you want to circulate the smoke in the whole building? So you shut down the air handling unit to one section of the air handling unit. So there's a lot of interface between the fire alarm panel and the security panel and other systems. Can I have thumbs up, Chad? We understand that interface. This is only one interface where you can have all these smoke detectors, one panel, interface with my security. Can I get you guys to understand the power for this? The security panel need a power, so you need to provide a power for it. Typically either plugged in or hardwired, panel. So for our project, the security system, guys, when they say draw a security riser, you're looking at this one. Can I have thumbs up, Chad? We understand if I say, Chad, draw a security riser, you're looking at a SP panel going to K, KP, and all these detectors. We don't want to have, we're not requiring a few of these here based on our project. All these wiring that you're looking at is typically, Aaron, my friend, you're talking about 16.2 or 16.4 cables between all these systems, 16.2 or 16.4. 18.2 is used too, 16 and 18. Can I use 14.2? Yes, typically 16.2 is good enough. What decided what size conductor do I need? The length, voltage drop. In low voltage system, guys, what decided is low voltage. A voltage drop. Do I need to pick a signal further away? So maybe I should get a bigger conductor so I can don't lose the 24 volt. Remember, you're dealing with 24 volt. 24 volt, it's easy to drop. You drop a couple of volts in 24 volt, and it's easy to exceed the limitation, the voltage limitation on the devices. Who cares? Your sensor is not going to pick up when you want them to pick up. Any questions, guys, about these? Any questions? So I wanted to go over these guys ahead of time before you start your low voltage system. So that's all what I have. I want you guys to read this chapter, please. I'm going to give you a few minutes here, and then I'm going to go over the requirement for the low voltage for our project just for 5 minutes, so you can hit the ground running, and then that will be it. Comments, questions? Jeff? Cool. Okay, thank you.